Hello and welcome to my vlog. It's January 1st, 2020, and I'd like to wish you all a very happy and prosperous new year. I've been reflecting over the things that we've done over the past year and some of the problems we've seen. And one particular thing I wanted to talk about today was the software design philosophy referred to as convention over configuration. The phrase itself was attributed, I think, to David Heinemeier Hansson, the creator of the Ruby on Rails framework, and that's the reference Wikipedia gives. And although the idea itself predates that, the idea of defaults was known long before that. The idea with this software design philosophy is that when you build a piece of software, in particular this seems to apply to frameworks, build systems and IDEs, you build it in such a way that it assumes a whole bunch of configuration parameters, and unless the developer tells it otherwise. This is a huge advantage for many systems, particularly large and complex systems where you'd like to get a new developer or a new user of your system to get started and start being productive with your framework or build system or IDE relatively quickly. They don't need to know a whole lot about how your framework works or how your software works, and that's easy. That makes it easy for them to get started and be productive. Compare this with a more traditional Unix software tool such as make, where basically you can, typing make on the command prompt will give you an error unless you specify a make file, which means you have to, as a developer that's new to make will have to spend a considerable amount of time learning how to learning how to write make files before they can even get started with doing useful things with make. However, with a tool like Gradle, just simply typing Gradle in it will take you through the necessary procedures to create a useful configuration that allows you to build an empty but functional application. And that makes, as I said, development very easy for newcomers to the tool or the framework. This does have a problem though, and by the way, one of the reasons why frameworks and build systems and pretty much every IDE prefers it is because it makes adoption of your framework that much easier. So it reduces a barrier to adoption, and that's very important to the creators of these software systems. And pretty much every modern framework across languages and IDE and build systems lately uses this design idea. It's definitely there in Ruby on Rails. Django for Python uses it. Many Java frameworks use it, including Spring Boot and Play and a few others. And many build systems use it. Maven uses it, and Gradle, as I said, uses it. And it's become quite ubiquitous everywhere. Pretty much every IDE, integrated development environment that you use, essentially has a set of defaults built in that will do something useful when you try to build your project. So, and this is quite ubiquitous now. The problems with this design philosophy are not evident to a user of this type of software early on. The problems start manifesting themselves a little bit later when you start getting to scale. When your software becomes sufficiently large, and you'll find that you need to do things that are not supported by default in the framework, and you go and try to change them, and you find that either A, it's very hard to do, or B, it's hard coded, which is even worse. You can't change that at all. And so you hit these limitations, and then by that time you've invested a lot of effort into building your application around that software tool or framework, and changing can be a huge problem. This is particularly relevant to DevOps engineers because often folks like us build systems in ways that and a developer typically would. Most developers, when they get started with the project, use their IDE, and they use that IDE project, IDEs build capabilities, and it works very well for them. However, when you scale to many developers and you need to build automated test suites, as a DevOps engineer, you'll almost certainly never be invoking a build from an IDE. You will actually be doing it from say, it'll be some script that gets invoked by Jenkins or something like that. So the environment under which you will build software, or your code will build software, will be very different from the environment in which a developer would work. And that makes it hard for, that makes DevOps engineers the people who encounter these problems initially. And the one thing I've noticed is build systems tend to scale much less well than, say, the frameworks, than software frameworks. So the size at which you'll run into problems with something like Django or Ruby on Rails or Spring Boot is far larger than the size at which you will encounter difficulties with, say, Gradle or Maven. The size, in this case, what I mean by size is the number of developers or the number of features or complexity of the code that you're dealing with. Increasingly, you will find that as a project goes bigger, it becomes polyglot, meaning many different languages and frameworks start being used, and building all of that consistently with a build tool becomes a problem, especially one that has defaults and is strongly opinionated about how things should be done, ends up being a problem. So what's a DevOps engineer to do? So one thing you can do two things. First thing, make sure you understand your build systems. You really need to know the innards of your build systems and software frameworks that you use, because at some point you'll have to tinker with their innards and make them do things that are very very unconventional. So that's important. So invest the time early upfront when you pick a framework, or when you enter into a project that's using a given framework, to become very conversant, not just with using it, but with the internals, how it works, what assumptions it makes, what sort of things it does. Study the code. The second thing is get comfortable and get really good at using build systems that focus on configuration rather than convention. So make is an example. So understand how to use make files, understand how to use ants if you're using Java, how to use ant, and you'll find that these sort of tools that don't impose an opinion on you scale much better. Indeed, one of the reasons why DevOps pipelines at large companies are wildly different from one another and deeply complicated and custom is because they have very large code bases that do things that are unique to their environment, and you won't find that particular need anywhere else. And and the DevOps teams within those companies have to solve those problems themselves, and that's one of the reasons why there are other reasons too. So that's my thought for the new year, and once again wish you a happy new year. I'll see you soon. Happy coding!